Good morning, dear students. My name is Ferhan Mazher, and today is 7th of October 2021, and the day is Thursday. And right now, I am with the 9 Cambridge class, and the subject we are studying is D Maths 4024. It's Cambridge O level mathematics, and we are working on the syllabus, and we are studying the book, and the name of the book is D3. We are working on the chapter number 1, and we are working on its exercise 1E. And this exercise is about drawing the graphs of the quadratic equations. And these quadratic equations, here we use the turning point of the quadratic graph and its x-intercepts and y-intercepts. With the help of these three things, we draw the graph. And let me show you, we have already in a previous lesson, we have already done the question number 1 and question number 2 of this exercise. Today, we are going to start from the question number 3. Okay, so let's start. And so here we go. So you can see here we go. So you can see that the question number 3 is coming up on the screen. Let me read it from the book, and then we will see how we solve it. It says factorize x squared plus 3x by 4. X squared plus 3x by 4. That's the first part. He says factorize it. And in the second part, he says hence sketch the graph y equals to x squared plus 3x by 4. So first of all, I'm going to factorize it. You can see here the equation is given x squared plus 3 by 4x. So you can take x common. These two terms, they have x common, so you can take x common. So because this is x squared, if you take x common, here x will be left. And from this term, when you take x common, so only 3 by 4 will be left. So this is how you factorize it. So the next question, the second part is, he wants you to draw the graph of this equation. So we know that y is equal to x squared plus 3 by 4x, and we have taken x common. So you will have x bracket x plus 3 by 4 bracket close. Here, I will do a trick. Here, this bracket is good. That is good for showing the x-intercept. Here we have only x. So what I will do, I will put this in a bracket and I will write x plus 0. So you can see here I have done that trick, x plus 0 in one bracket and x plus 3 by 4 in the other bracket. So now you can clearly understand that this is that x-intercept form. And you know that this, when the equation is like this, y equals to x plus 0 and x plus 3 by 4. So these two brackets, these constant numbers here, they represent the x-intercepts. So it means that the x-intercept, the x value will be 0. So the coordinates will be 0, 0. And this 3 by 4, so the x-intercept will be at, you change its sign, minus 3 by 4, 0. So from this equation, I can directly tell you what are the x-intercepts. So these 2 points, when the equation is like this, these 2 points, these 2 constants here, they actually tell you the x-intercepts. You just have to change their sign, and that will be the x-intercept. X-intercept means when the graph will cut the x-axis. So once you know the x-intercepts, then the next thing we will find the x of the turning point, x coordinate of the turning point. X coordinate of the turning point is, you know, the x-intercepts. You add them up and you divide them with 2. So that will be the x of the turning point. So you see here, you can see that we have added these 2. So I will add 0 and minus 3 by 4, and I will divide it with the 2. So 0 plus minus 3 by 4, that will be minus 3 by 4 divided by 2. So I convert this divide into multiply. So this will become, this 2 will become 1 by 2. So now it will be minus 3 by 8. So the x coordinate of the turning point will be minus 3 by 8. Now I will find the y of the turning point, where the graph takes a turn, parabola takes a turn. I will find its y coordinate. The point, the turning point, I will find its y coordinate. For that purpose, I will use the original equation, this one, And there I put the x value minus 3 by 8. I will substitute the x with minus 3 by 8. You can see here, we have put minus 3 by 8 in the place of x. So 3 square will be 9, 8 square will be 64, minus square will be positive. This will become minus, and 3 is a 9, 4 8 is a 32. So I will take the, here you multiply, because these are two terms and they have denominators and then they are subtracting. So what I will do, I will make the denominator same. So in this fraction, you multiply with the 2, so you have 18 by 64. So 9 minus 18, that's minus 9 by 64. So you see the turning points coordinates are minus 3 comma 8, sorry, minus 3 by 8 comma minus 9 by 64. And if you convert this into the decimal fraction, that will be minus 0.375, and this will be minus 0.1406. Now I will try to find out the y-intercept. Whenever you want to find out the y-intercept, in this equation, in the place of x, I will put 0. So when you put zeros, the y will be also 0. So the y-intercept will be 0, 0. So now I know that the x-intercepts are 0, 0 and minus 3 by 4, 0. I know the turning point is, the coordinates of the turning point is minus 3 by 8, minus 9 by 64. And the y-intercept is 0, 0. So I will draw this. So here you can see that we have drawn a grid. And this grid we have drawn a rough hand grid. You can do this in actual graph paper. And you can see I have taken 4 centimeter equals to 1 on the x-axis on both the side, positive, negative side. 4 centimeter represents 1. And on the y-axis, I have taken the same scale that 4 centimeter represents 1. Then I plotted the x-intercepts. The x-intercept was minus 0.75, 0 and 0, 0, and the turning point was minus 0.375, minus 0.1406. I plotted these 3 points and I joined them with the smooth curve. So you can see this is the graph. This is the graph of that equation, and I hope that you have understood. So that was the question number 3. Let's move to the next question. The next question coming up on your screen is question number 4, and let me read the graph for you, the question for you. It says sketch the graph of y is equals to minus bracket start x square minus x bracket close. So that's the only statement in that question. So here we have an equation, y is equals to minus bracket x square minus x bracket close. So the first thing I will do, I will take x common. And one very important thing, because here the x square will be negative, that's why the graph will be a sad face. Okay, so the parabola will open downward, so it will be a sad face. So you can see I have taken the x common, and you are left inside the bracket with x minus 1. I will do the same trick again. Here you have a bracket x minus 1, and with this x outside, I will write x minus 0 or x plus 0 you can write. So when you have this form, this negative, outside negative means it's a sad face, and x minus 0, x minus 1, this form of the equation actually tells you the x-intercepts. So this number here tells you the x-intercepts. So the 0, 0 will be 1. This is the x-intercept, so 0, 0. This number is also telling you the x-intercept, but you have to change its sign. Here it is minus 1. The actual x-intercept will be positive 1. So positive 1, 0. At the x-intercepts, the y value is always 0. Remember that thing. At the x-intercepts, the y value is always 0. So you will have 0, 0 and 1, 0 as the x-intercepts of this graph. And you know the x-intercepts of the graph means that these are the points where the graph will cut the x-axis. So once you know the x-intercepts, the 2 x-intercepts of this graph, you can find the x of the turning point. The x of the turning point you can find by adding up these x-intercepts and dividing it by 2. So here you can see we have written the formula 0 plus 1 divided by 2, that will be 1 by 2. So I know the x-intercept, and then I can find out the y coordinate of the turning point. So I know the original equation. In the original equation, just put the x equals to 1 by 2. The x coordinate of the turning point, put that x value in that original equation. So you will have y equals to minus 1 by 2 bracket, and you can see in the place of x, we have substituted 1 by 2. So we will have 1 by 2 minus 1. So inside I will take the LCM. So it will be 2. So 1 minus 2, 1 minus 2 is minus 1 by 2. So this thing will be minus 1 by 2. Outside also we have minus 1 by 2, minus will be plus. 1 multiply 1 will be 1, 2 multiply 2 will be 4. So the y coordinate of the turning point is 1 by 4. So the turning point coordinates will be 1, 2 and 1 by 4. So 1 by 2, 1 by 4, 0.5, 0.25. So now I will find the y-intercept. So whenever you find the y-intercept, the strategy is very simple. What you do, you take the original equation, and in that original equation, in the place of x, you put 0. So take the original equation, and in the original equation, put x equals to 0. So you can see here, in the original equation, we have put x equals to 0. So y will be also 0. So 0, 0 will be the y-intercept, the coordinates of the y-intercept. So I will plot these points. You can see this 0, 0, this x-intercept, 1, 0. This is the second x-intercept. And the y-intercept is also 0, 0. Okay, this point, the turning point is 0.5, 0.25. So here you can see we have put that point. And another point, I just found these 3 points are enough to draw this. This point is not there. This point was by mistake I wrote. And these 2 points, I just put the negative -1 value in this equation and positive 2 value in this equation. And I found the y value in the original equation. I put the x equals to -1. And in the original equation, I put x equals to 2 and found the value of the y's -2. So I plotted this point, these 2 points, and then I joined them with a smooth curve. And you can see the scale, 4 centimeter equals to 1 on the x-axis, 4 centimeter equals to 1 on the y-axis. So this is how you will plot this graph. So the next question coming up on your screen is question number 5, exercise 1E. Let me read the question from the book. And it says, factorize x squared plus x minus 6. That's the first part. And then he says, hence sketch the graph of y equals to x squared plus x minus 6. Okay, so the first part is that here an expression is given, x squared plus x minus x. And I will multiply the extreme terms, and that will give you 6x squared. And I will write the pairs which by multiplication give you 6. That is 1 and 6 and 2 and 3. So with the third term, you can see we have a negative. So I will write here subtract. I have to choose that pair, which by subtraction will give you +1, which is the middle term. So with the larger number, I will put positive sign. With the smaller number, I will put a negative sign. So here you can see we have done the midterm breaking. The extreme terms remain as it is. So we will have x squared minus 2x plus 3x minus 6. So I will take here x common. So you will have x minus 2 inside the bracket. From the last 2 terms, I will take plus 3 common. So you will have x minus 2. So now you can see this bracket is common. So I will take this bracket common. So you will have x minus 2 from here. You will have x from here. You will have 3. So you can see that we have completely factorized x squared plus x minus 6. Now, the second part is y is equal to x squared plus x minus 6, and they want you to draw its or sketch its graph. And we know that when I will factorize this expression, I will get this x minus 2 into x plus 3. So you can see that this is that form of the quadratic equation in which you can very easily tell what are the x-intercepts. The x-intercepts are, you see this number in this bracket, -2, you just change its sign, and that's the x-intercept. So the x-intercept will be 2, 0, and this is the second number, you change its sign, it will be -3, 0. So So you see from this equation, very easily I can tell what are the x-intercepts, 2, 0 and -3, 0. Now, once you know the x-intercepts, very easily you can find the x of the turning point. So the x of the turning point will be, you add up both the x-intercepts and you divide them with the 2. So you will have 2 plus bracket -3 bracket close divided by 2. So it will be -1/2. So the x coordinate of the turning point is -1/2. So once you know the x coordinate of the turning point, you will find the y of the turning point. The y of the turning point, take the original equation. For example, I took this form of the equation, and in the place of x, I will put this value. So I substituted the x with the -1/2. So you can see here -1/2 -2 in one bracket, -1/2 plus 3. So -1/2 -2, that will be -5/2. We took the LCM. So it will be -5/2, -1/2 plus 3. We take the LCM. So it will be 5/2. Just multiply both these terms. You will have -25/4. Now I know the y coordinate of the turning point. So the turning point's coordinates will be -1/2, -25/4. In decimal fraction, it will be -0.5, -6.25. Okay. Now we will find the y-intercept. So if you want to find the y-intercept of that equation, that graph, what you will do in the equation, in the place of x, just put 0, because when the graph cuts the y-axis, the x value is definitely 0 there. So y equals to 0 -2 in one bracket, and in the other bracket we have 0 plus 3. So it will be like -2 multiplying with the 3, and that will be -6. So the y-intercept is 0, -6. So it will be a happy face. We know that because this x square is positive. So it will be a happy face. So here you can see I have chosen a grid, and 2 centimeter represents 1 on the x-axis and 2 centimeter represents 1 on the y-axis. Then I plotted my x-intercepts, 2, 0, this point, and -3, 0, this point. My turning point is -0.5, -6.25. I have plotted this point, and you know the y-intercept is 0, -6. And you know, around this point, the graph is symmetrical. So if you move 0.5 here, and the value will be -6, same 0.5 you move. If you move 0.5 to the left side, the value there should be -6. So you plot these points and then you join them with the smooth curve. So this is the graph of y equals to x squared plus x minus 6. Hopefully you have understood. This is the question number 5 of exercise 1E. Okay, so we are moving to the next question, and the next question is question number 6 from the exercise 1E. And you know, it says sketch the graph of y equals to x squared minus 6x plus 3. So we have y equals to, I will try to factorize it. And you know, I will multiply the extreme terms here. You see, and you multiply that, it gives you 3x, and the pairs of the pairs which multiply by multiplying give you 3. There's only one pair. That's 1 multiply 3, or 3 multiply 1. By addition, I should get 4, but I want -4. Yeah, I want -4. So we will take 3 and 1. 3, 1 multiply with each other give you 3, but when you add them, that give you 4, but we want -4. So with both of them, we will put negative sign. This is the midterm breaking. And x squared minus 3x minus 1x plus 3, you can see the extreme terms are same, but we have broken the midterm. From the first 2 terms, you can see the x is common. So we'll take the x common. So you will have x minus 3. From the last 2 terms, -1 is common. So you will be left with x, but if you take a negative common, this sign will change. You're left with -3. Now you can see both these terms, they have x minus 3 common. So I will take that bracket common. From here, x will be left. From here, -1 will be left. So you can see this is the factorized form. We have factorized it. And you know, this is the famous form in which you can very easily tell what are the x-intercepts. And you know that this number here, that actually shows the x-intercept, but you have to change its sign. Here it is -3, the x-intercept will be positive 3, 0. Here it is -1, the x-intercept will be +1, 0. So now I know the x-intercepts. Now we will try to find out the x-coordinate of the turning point. For that purpose, what we will do, we will add up the x-intercepts and we will divide them with 2. We divide that sum with 2. So you will have x plus 1 divided by 2, that will be 4 by 2, that will be 2. So now we know the x coordinate of the turning point. So we will take the original equation, and in that original equation, in the place of x, I will substitute 2. So I will get the value of the y. You can see here, I have done that. So the value of the y came out to be -1. So the coordinates of the turning point are 2, -1. So you see in this graph, I know the x-intercepts, 3, 0, 1, 0. I know the turning points coordinates, that is 2, -1. The x squared coefficient is positive, so this will be a happy phase. Now, one last thing I will like to do, that is to find out the the y-intercept. So for that purpose, whenever we find the y-intercept, the x should be 0 at that point. So take the original equation, and that original equation, in the place of x, substitute 0. So you can see we have taken this form, and in the place of x, I put 0. So you are left with -3 multiplied with the -1, that will give you +3. So the y-intercept will be 0, 3. So now you see I have the x-intercepts, I know the turning point, I know the y-intercept, and I know it will be a happy fix. So here you can see that we have taken a grid, and that grid is a freehand. I've drawn it freehand on that whiteboard in my class. But you can do it on an actual graph paper, centimeter graph paper we normally use. So you can see we have taken 1 centimeter equals to 1, and then we plotted the x-intercepts. First of all, the x-intercepts are these two, 1, 0 and 3, 0. Then we have plotted the turning point, that is 2, -1. And then we have plotted the y-intercept, that is 0, 3, this point. And you know that this is the turning point, and around the turning point, the graph is symmetrical. So if you move 2 steps here, you move 3 steps up. So same way, 2 steps here, 3 steps up. So you found this point because the graph is symmetrical about this point. So I will join these points with the freehand smooth curve, and we got that graph. So this is question number 6, and this graph, hopefully you will be able to draw this graph. You will be able to recognize this graph. Okay, my dear students, so we are moving to the next question. The next question coming up on your screen is question number 3 from the exercise 1E. So let me read that question for you from the book. The first part of the question number 7 is, he says, express x squared minus 8x plus 5 in the form bracket x minus p bracket close whole square plus q. He wants you to represent this thing in this. And remember, this form, how you convert? By applying completing the square method. So that's the first part. So let's first of all do this first part. So the procedure is very simple. If you have not seen my video on the exercise 1A, kindly see that. There I have taught how to apply the completing the square method. But here, let me do it again. So this is the original expression, x squared minus 8x plus 5. For applying this process, the first thing which is important is that the x squared should be positive. It should have 1 as coefficient. The coefficient of the x squared must be 1. Okay, so it is. Here, the coefficient of the x squared is 1, so there is no problem. Then what we do in our rough work, we take this x term, we write it and we divide it with 2x. So I took this x term in my rough work and I divided it with the 2x, that's the rule. And whatever the answer comes, whether a single number or a fraction, whatever, you add it square in your expression and you subtract it square from your expression. So here you can see I have written x squared minus 8x plus 4 squared minus 4 squared plus 5. So these three terms, they make x minus 4 whole square. And this is minus 16, this is plus 5, so x minus 4 whole square, and this give you minus 11. Now you can see that this has been converted into this form. So this is how you apply completing the square. Now the second part. Hence, sketch the graph of y equals to x squared minus 8x plus 5. So we have to draw its graph. So here y is equal to x squared minus 8x plus 5, and we know that by applying completing the square, I can write this expression in this form. So y is equals to x bracket x minus 4 bracket close whole square minus 11. So this form of the quadratic equation, this gives you directly the turning point's coordinates. This form of the quadratic equation gives you the coordinates of the turning point. So this number here, which is inside the bracket with the x, that gives you the x coordinate of the turning point. You only have to change its sign. And this number outside, this gives you the y coordinate of the turning point, and you take as it is. So I will change its signs, 4, comma, minus 11. So you see this form of the equation gives you the coordinates of the turning point. So the turning point will be 4, comma, minus 11. 4, comma, minus 11 will be the turning point. So once you know the turning point and you know that the quadratic graph, this x square is positive, so it will be a happy face. So this is the turning point, 4, comma, minus 1, minus 11, sorry. If you know the turning point, you take 3 points before the turning point and 3 points after the turning point. So the x of the turning point is 4, so I will take 3, 2, 1. And I will take few points after this point, 5, 6, 7, 8, for example. And I will put these x values in this original equation, and I will find what's the value of the y. So you can see here, I have completed that table. Now I will plot these points on the grid. You see, once you know the turning point, the very simple rule is you take 3 points before the turning point and 3 points after the turning point. And that will be enough to plot the graph of this quadratic equation. So I've drawn here the grid. 1 centimeter represents 1 on both the axes. You can see here we have drawn the graph. Okay, so you have the 4, comma, minus 11. So 4, comma, minus 11, this is the turning point. I put a dot here. Then 3, comma, minus 10, 3, comma, minus 10, 5, comma, minus 10, 5, comma, minus 10 here. 2, comma, minus 7, that's the point here. And 6, comma, minus 7, this is the point. And 1, comma, minus 2, this is the point. And 7, comma, minus 2, this is the point. So simply join them with the smooth curve, and this will be your parabola. This will be the graph of this quadratic equation. Now, the vertical line which is passing through this turning point, that is the line of symmetry. Because here in the question number 7, in the third part, he says, write down the coordinates of the minimum point of the graph. And the fourth part is, state the equation of the line of symmetry of the graph. So 2 things they are asking. They are asking for the minimum point. This is the minimum point. And they want its coordinates, that they are 4, comma, minus 11. That's the coordinates of the minimum point. And then they want you to write down the equation of the line of symmetry. This is the line of symmetry. The line of symmetry divides the graph into 2 equal parts. And when you fold them, they will coincide, they will come over each other. So this is the line of symmetry. It's always a vertical line, and its equation is always x equals to constant, and that constant here is 4. So the line of symmetry equation is x equals to 4. So this was question number 7. I hope that I have made my point clear. I hope you can do it yourself. So let's move to the next question. So on your screen, the question number 8 is showing up, and you can see. Let me read that question from the book, and let's see what happens. It says, by first expressing x squared plus 3x plus 1 in the form x plus p whole square plus q. So we have to represent it in this form. They have written x plus b whole square plus q, and write down the coordinates of the minimum point of the graph. So we want to write down the minimum points of the graph, and they have not actually asked to draw the graph, but we have drawn it so that you can understand. So first of all, I will apply the process of completing the square on this right side. So the first condition for applying the completing the square is that this x square should have coefficient 1. Its coefficient should be 1. So then it is 1 here, so it's good to go. So what you do, you take the term which has 3x, which has x, you take that term in your rough work and you divide it with the 2x. So whatever the answer you get, you take it square, add it, and you subtract it. So now you see in my rough work, I've written 3x divided by 2x, that gives you 3 by 2. So I will square the 3 by 2 and I will add it and I will subtract it. Okay, so here we have x squared plus 3x plus bracket 3 by 2 bracket close whole square minus 3 by 2 bracket close whole square plus 1. So these three terms, they will make x plus 3 by 2 whole square. So these make formula x plus 3 by 2 whole square. This gives you minus 9 by 4 plus 1. So you take the LCM, it will be minus 9 plus 4, it will be minus 5. So you have x plus 3 by 2 whole square minus 5 by 4. So the coordinates of the turning point are, you see this point, this is the shape which give you, this is the shape of the quadratic equation which give you the coordinates of the turning point. And they also give you the turning point will be, and this is a happy face, this is happy face always have a minimum point. You can see it's happy face. The happy face always has a minimum point. So what we will do, the turning points coordinate, this is the x coordinate, but you always need to change its sign. So it will be minus 3 by 2. This outside, the number which is outside, that gives you the y coordinate of the turning point, and you take as it is. So minus 3 by 2 comma minus 5 by 4, that's the coordinates of the turning point. So now I want to draw its graph. So once I know the turning point, what I will do, I will take 2 or 3 points before the turning point and 2 or 3 points after the turning point. So because the turning point is minus 1 at x equals to minus 1.5, so I will take 2 points before it, I will take 2 points after it. So I will take minus at x minus 3 and x minus 5, and same way I will take x minus 1 and 1. So 2 points before that and 2 points after that. I can take 3 points also. So when I put these x values on in this original equation, I get these y values. So then I will plot them. So you know I have drawn here a grid. 1 centimeter represents 1. And the turning point is minus 1.5 comma minus 1.25. So here we have that point. I plotted it. And at minus 1, the value is minus 1. At minus 3, the value is positive 1. At minus 5, the value is 11. Here is that point. At 1, the value is 5. So then I join this point with the smooth curve, and you can see that we have got a graph whose parabola, who's the happy face, and the coordinates of the minimum point. The coordinates of the minimum point are this point, and this is the same, it's the turning point, the coordinates of the turning point. So the coordinates of the minimum point will be minus 3 by 2 comma minus 5 by 4. So that is question number 8. Hopefully you have understood. So let's move to the next question. Okay, so my dear students, these are now the question number 9 of the exercise 1E, and they are advanced level questions. And let me read the question from the book, and it says, the graph of y equals to bracket x minus h bracket close whole square plus k has a minimum point at minus 1 by 2 comma 3 by 4. He says, state the value of h and of the k. You know, here, this h and this h actually tell you the coordinate, x coordinate of the turning point. And this k here tell you the y coordinate of the turning point. But here you have to change, its sign must be changed. So the h value will be 1 by 2, minus 1 by 2, I mean. And the k value will be same, whatever this here it is. That will be 3/4. Okay. So now I know the coordinates of the turning point. The minimum point is actually the turning point. So once you know the coordinates of the turning point, you can put them here. You can take them here. So the actual equation is y equals to x. When you put h minus 1/2, this will become positive 1/2, 3/4. So this is that original equation. So that is like x plus 0.5 whole square plus 0.75. So in this equation, I will take 2-3 points before the turning point, 2-3 points after the turning point. When I put these x values in this equation, I get the y values. Okay, these are the y values I got. By calculation, I got them. I put x here. For example, I put this point 0, and I get this value of the y. I put x1, and I get y equals to 3 from this equation. I did this calculation. You can also do this. Then we have plotted a graph here, and you can see the graph. I have taken 2 centimeters equals to 1 on the x-axis, and 1 centimeter equals to 1 on the y-axis. And then we plotted these points. So turning point is at minus 0.5, comma 0.75. So this is that point. And then we have at minus 1, we have 1. So this is that point. At 0, we have 1. This is that point. 1, 3. This is the point. 1, 3. Then we have 3, 13. 3, 13 will be here somewhere. And 2, 7 will be this point. And on this side, we have minus 2, 3. Minus 2, 3 will be this. And minus 3, 7 this. Then I will join them with this smooth curve. And you can see this is the graph we're looking for. So then he says, and sketch the graph of this equation, indicating the coordinates of the point of intersection of the graph with the y-axis. So when the graph cuts the y-axis, you can see this is that point, and its coordinates are clearly 0, 1. So that is the question number 9 of the exercise 1E. Hopefully you have understood. This portion was little tricky. Let's go. Okay. So we are moving to the next question, and that is question number 10 from the exercise 1E. D3 is the name of the book, and the subject is DMaths 4024. Okay, so let me read the question. He says, it is given that minus x square plus 10x minus 4 can be expressed in the form minus bracket x minus p bracket close whole square plus q. So this is that form we want. By first finding the value of the p and of the q, sketch the graph of y equals to minus x square plus 10x minus 4, indicating the coordinates of the maximum point of the graph. Okay, so you know this, what I will do, I told you that the x square must be positive. So what I will do, I will, from this expression, I will take minus common. So inside the bracket, you're left with x square minus 10x plus 4. So now inside the bracket, this is positive 1. So it's good. And the coordinates of the x square should be plus 1. They are, so it's good to go. So I will take this minus 10x. I will write it in the rough work 10x, and I will divide it with the 2x. So whatever the answer comes, I will square it, and I will add it, and I will subtract it. So here you can see x square minus 10x plus 5 square minus 5 square and plus 4 bracket close. So inside the bracket, these two terms, they will make x minus 5 whole square. Here this will be minus 25, and that will be plus 4. And now you have x minus 5 whole square minus 21, brackets around it, and minus 1 outside. So bring this minus inside, so it will be minus bracket x minus 5 whole square, and this minus and this minus plus 21. So so this is how you use the completing the square to make that form which they have demanded. This one. So from here, I can tell you, by comparison, I can tell you the value of the P. If you compare it, the value of the P will be positive 5, and the value of the Q is positive 21. So the coordinates of the turning point of this graph will be 5, 21. It will be a sad phase because the coefficient of the x square is negative, so it will be a sad phase. And the coordinates of the turning point, you know, this form of the equation actually tells you the coordinates of the turning point. This negative means it will be a sad face. -5 will be representing the x coordinate, but you have to change its sign, so it will be +5. And this is taken as it is. This represents the y coordinate of the turning point. So 5,21 is the turning point. So my dear students, once you know the turning point, you write it in the table. This is the turning point, and you can see 5,21. If once you know the turning point, you take 3 points before the turning point, 3 points after the turning point, and you put those x values into this original equation and find the y values. And you can see in this original equation, I substituted x as 4, x as 3, x as 2, x as 1, x as 6, x as 7, x as 8, x as 9, found the values of y. You can see I've written them here. Then I will draw a grid here. So you can see the grid here clearly, and 1 centimeter representing 1, and I will plot this. So the first point I'm going to plot is the turning point. That's 5,21. So you can see here we have 5,21. And 4,20 is this point, then 3,17, then 2,12, 1,5. On this side, 6,20, 7,17, 8,12, 9,5. After plotting these points, I will join them with the smooth curve. So this is how you draw the graph of this equation. Their point is indicate the coordinates of the maximum point. The coordinates of the maximum point are 5,21. Here where the graph, this is the turning point of this sad face, and that is the maximum point. And sorry, maximum point, and its coordinates are 5,21. So that was the last question in the exercise 1E from the book B3, and this was about the graphs of the quadratic equation. So my dear students, this was I think so my dear students, this was exercise 1E from the D3 DMAS 4024. I'm working with the 9th Cambridge class, and I hope that this video will help you. It will help you to improve your concepts of mathematics. And by sitting in your home, by just watching at these YouTube videos, and you will be able to learn this trick and this concept. You will be able to master this concept. Remember one thing, you learn mathematics when you actually practice the questions. So please watch these videos and also practice them at your home. So I hope that I am to some help to you. If this video is helpful to you, don't forget to subscribe to my YouTube channel and also like my videos. And don't forget to share these videos on your Facebooks and your Instagrams. That will be a great appreciation for me. So thank you very much and have a good day.